My name is Brian Merton. We are Group 7. We did a project on Engineers Without Borders. The way we divided our responsibilities is sort of chronologically. I took the history and literature survey portion. Nelvin did the current and modern projects that are being done, and Juan did the design and future concepts. So the first question is, what is Engineers Without Borders, often abbreviated EWB? It's a non-profit organization, and basically what it is engineers coming together and helping people who are less privileged in either other countries or in their own country, domestic and international. Often it is international in third world countries, in places that really have very little resources, and people who can offer their best to help these people using their knowledge of engineering studies and research. The experience ranges from undergraduate students all the way to masters in their crafts who have been doing this for decades. Oftentimes it's somewhere in the middle where you'll have one master engineer and several engineering students, and then some volunteers who are still working in the field. Engineers Without Borders is mainly known for the civil engineers, environmental engineers, engineers who work with alternate energy sources, but it also has a big field for mechanical engineers and electrical engineers as well. So I want to talk a little bit about the history of Engineers Without Borders. It began in the mid-1980s with France. ISF is their acronym for Engineers Without Borders, and in the early 90s, Spain and Italy also joined the ISF movement. By the late 90s, you had several countries across the world who were helping the Engineers Without Borders movement. You also had a lot of private companies emerging at this time, and in the late 90s, Canada emerged as one of the greatest organizations, one of the largest organizations for the EWB movement, and still today they are one of the largest and most notable EWB organizations out there. In 2001, the U.S. got into the race. The University of Colorado Boulder, they are the ones who founded the EWB US. The same year, Cornell University, they founded what was called the EWF in US, which is Engineers Without Frontiers. That name was later changed to Engineers for a Sustainable World for legal issues, but basically they had the same goals, helping others using their engineering knowledge to help those in need for a not-for-profit sort of way. The fundamental difference between the two is Engineers for a Sustainable World. They're a little bit more creative, a little bit more modern in their designs and in their ideas. They're known for coming up with the solar tree. They also came up with the tiny house movement that swept the country a few years ago. EWB is a little bit more rugged, a little bit, more mud on the pants, and they like going to third world countries using all the resources that are there, which usually aren't much, to solve a problem, whatever it may be, for those in need. Some of the notable projects that are going on in the EWB in the U.S. portion. Here on the left we have the founders of EWB, which is Colorado Boulder. This is a photo of them about 10 years ago in Southern America, where they installed a manual pump. On the right you have USC in Honduras making a water wheel, and as you can see, the resources that they're using are not anything special. They're very, very raw. They have a PVC pipe, a very old motor, a rusty water wheel, but this is what EWB is about. It's about using what's there to help people in need. A couple more photos. On the left is the Israel Institute for Technology, and on the right you have Marquette University in Guatemala making a pipeline. But you can see again how these individuals, these engineers, are using whatever they can find, and they're repurposing them to solve the problem and help these people in other countries.
Hi, I'm Melvin Sherry, and I'm going to present about some current projects going on with Engineers Without Borders. One of the projects going on is from California Polytechnic University, and within that chapter of Engineers Without Borders, they're trying to build an elementary school for about 151 students in Nicaragua in the Barrio William Galenio area, because there's children there who don't have access to a local area school to go to. So they planning to implement a plan of a school that has three rooms and one office in it, located in it, and they raised the money for the plans themselves. And as a general rule, with every Engineers Without Border project, the community has to raise about 5% of the cost to build a project in order to have ownership rights. And then the next project is from the University of Cincinnati chapter of Engineers Without Borders, and this chapter wanted to build a water well in Nambogo, Tanzania, because they didn't have access to clean water, and for this project they haven't implemented it yet, but they have to do an assessment of the area, and a big portion of dictates how the water well is going to go down is they have to do an initial drilling to see what the water quality is like and everything, and they have to raise the funds, and the community has to raise 5% as usual. And then the next project I'm going to talk about is a project in a high school in Ghana, and this high school is Clifford Prezo Senior High School, and they wanted to implement a better bathroom system within that high school, because currently right now that high school has about 20 KVIP land shrines, and basically land shrines are like pits in the ground in order to use the bathroom, and the problem with that is that they get filled, and then there lies the problem with odor issues, and then sanitation issues, because within Ghana they don't have complex piping systems, plumbing systems. So in order to implement this plan, they have to really think of a way to get around that, because that's a limitation to getting towards that. They can only work with what they have right now, and they're currently working on that.
Hello, my name is Juan Cardona. As Engineers Without Borders, our mission is to go out around the world using engineering to create projects that are going to help the community be a better place. One of the biggest crises in the world right now is being able to have access to clean water. Believe it or not, there's a lot of countries throughout the world that don't have this privilege that we have. So we wanted to base our project to help this cause. We wanted to create something that will help this. So we decided to base it in helping Somalia, which is a country in Africa, which is ranked the #1 country that doesn't have access to clean water. There's actually about 840,000 people that die each year because of diseases caused by drinking contaminated water. Some of these diseases are Salmonella, E. coli, cholera, rotavirus. What these viruses do is a lot of them, they cause you to vomit, have diarrhea, have worms in your stomach. They actually dehydrate you. So what we wanted to do is create a project that will send a group of people to Somalia to facilitate them with life straws, which are the ones that you see here in the picture. A life straw is it's a straw filters contaminated water. It kills the viruses, 99.9% of the viruses that are in it. What it consists of is inside on the bottom. There's a filter that first stops all the algae and other plants and insects from going in. Then it goes through another hollow fiber membrane, which allows only 0.2 microns to go through it, which means that it pretty much only allows water to go through it and kills all the bacteria that goes inside. And then it goes through another membrane, another filter, and then it goes through iodine beams that kill parasites, which are this right here. And then they finally go through through a chamber of granulated activated carbon that kills parasites as well. And then finally it goes into your mouth, and then you drink it and it's clean. People can use it, and it's really easy. You just basically would just go to any source of water that you want. It could be a lake, a river, even rainwater if you would like, and just stick the straw in the water and just drink from it like you would drink from any straw. So after doing a little bit of research, what we decided to do is work with the live straw, but we'll give it a little twist. We wanted it to make a new design so that it would be possible to filter out the contaminated water, but as well to give it flavor. So this is the new design that we came up with. This is the new live straw that we came up with, which is actually like about an inch longer than the old one, the original one, and it's basically the same thing as a filter wise. It goes into the first filter, then the second filter, third filter, the iodine beans, the carbon, and then what we did is with the extra inch that we got in the new design, we created like an extra membrane that can hold like a tea bag function that has flavor in it, which is this little green thing in it. Basically, how it works is you take off the top of the straw, which is this. You take it off, and then you introduce the flavor that you want. It could be lime, apple, orange, any flavor that you want, and it will last you about a week. So it acts just like a tea bag. When you put a tea bag in water, that it gives flavor, just like that. The water will go through a filtrate, it will get to the top, and get the flavor, and then it goes in your mouth, and you drink it. And we did this because here in America, a lot of people use the straw, but for emergency situations when they go camping or hiking or anything like that. But in Africa or in Somalia, which is the country we want to help, it's their main source of water. So we just don't want them to survive, but also to enjoy what they're drinking. So that's why we came up with this design.